Hello, my name is Arhan Bilici and I'm a student in Mechanical Engineering department. Today, I will present you the experiment that I did for my Physics 101 laboratory project. My experiment uses the setup simple pendulum in order to derive the full formula that describes the period of oscillations. I collected data by varying mass of pendulum bob, length of rope, gravitational force, and release angle. Using these data, I showed the correlation of period with these variables and obtained experimentally derived constant by combining these data. The slope of best fitting line was the derived constant that I obtained. Now let's check the steps of the experiment.
The first step was changing the angle. While changing the angle, I tied my protractor into my system. This system helped me arranging my angles in a very efficient way. As you can see, the system worked successfully and I arranged the release angles of the motion in a very sufficient way. To obtain the most precise results, I repeated every angle's motion 6 times and the results clearly show that the angle doesn't affect the duration of the period. The next step is changing the mass of pendulum bob. For this step, I used 5, 10 and 20 grams of masses and I stick them together to obtain different mass values. I also repeated the motion for different mass values in order to obtain a precise result. The results show that the mass of the pendulum bob doesn't affect average period. Human-based errors cause the small differences between average periods, but the small differences are non-significant. Now let's check the next step, which is changing the length of the rope. While changing the length of the rope, I released the pendulum bob from 10 degrees, and the mass of the pendulum bob was chosen as 10 grams. I chose the strings with lengths ranging from 10 to 60, increasing by 10. This means I worked with lengths of 10, 20, 30, 40, 50 and 60 centimeters. Once again, I applied repetitive method in order to obtain precise results. If we check the results, when we multiply L with any number, T increases with the root of that number. So we need to sketch the graph for T and root L. The linear shape of this graph shows us that T and root L is directly proportional. In the final part of experiment, I used this cube to lift the aired plane and the aired plane helped me to change the gravitational acceleration. I also used the same protractor system in order to measure the release angle. I set the sparkometer to 50 milliseconds and read the marks from the paper. If we check the results, we can see that T and G is inversely proportional. And checking more detailedly, this inversely proportion shows that T is related with root of G. We can conclude that T and 1 over root G must be correlated and this correlation must be linear. So this graph proves the relation. We found that T is correlated with root G and root L. But this can't be the final formula since if we apply the formula, the result of period is wrong. So this means that we need a constant. And to find the constant, we must check the graph of T times root G over root L. Slope of this graph, which is 6.31, gives us the experimentally derived constant.
If we compare our constant with 2 pi, we have derived the constant with 0.4% error. So in the end, we have derived the full formula and the constant with small error. Thanks for listening.